NASA's Webb telescope discovers possible direct collapse black hole. A groundbreaking discovery. The mysterious infinity galaxy and the birth of a supermassive black hole. Imagine a cosmic oddity so unusual that it has left scientists stunned. Meet the infinity galaxy, a mysterious object that has been hiding in plain sight, waiting to be discovered by NASA's James Webb Space Telescope. This enigmatic galaxy has a shape that resembles the infinity symbol, with two compact red nuclei surrounded by a ring. But what's even more astonishing is the presence of a supermassive black hole at its center, which may have formed through a process known as direct collapse. The unlikely formation of a supermassive black hole. The discovery of the infinity galaxy was made by two researchers, Peter van Dokkum of Yale University and Gabriel Brammer of the University of Copenhagen, who went examining images from the Cosmos Web survey. As they delved deeper into the data, they realized that this galaxy was unlike any other. The supermassive black hole at its center was not located in either of the two nuclei, but rather in the vast expanse of gas between them. This unusual placement sparked a series of questions. How did this black hole form? And what can it tell us about the mysteries of the universe? Theory for black hole formation, light seeds and heavy seeds. The formation of supermassive black holes is a long-standing question that has puzzled scientists for decades. There are two main theories, the light seed theory and the heavy seed theory. The light seed theory proposes that small black holes form when a star's core collapses and explodes as a supernova. These small black holes then merge over time to become a more massive black hole. However, this process takes time, and the universe's most massive black holes seem to have formed too quickly for this theory to explain. The heavy seed theory. A new perspective on black hole formation. The heavy seed theory, on the other hand, suggests that a massive black hole forms directly from the collapse of a large gas cloud. This process is much quicker than the light seed theory, but it's not clear if it's possible in practice. Gas clouds tend to form stars as they collapse rather than a black hole. However, the discovery of the infinity galaxy may have provided a clue to how this process could work. The collision of two disk galaxies. A possible explanation. Peter van Dokkum, the lead author of the paper, explains that the infinity galaxy may have formed when two disk galaxies collided. This collision would have caused the gas within the galaxies to shock and compress, creating a dense knot that could have collapsed into a black hole. The presence of a large swath of ionized gas, specifically hydrogen that has been stripped of its electrons surrounding the supermassive black hole, supports this theory. A test of the theory, measuring the velocity of the gas and the black hole. To test this theory, the researchers applied for and received director's discretionary time to follow up on this target with Webb. Their preliminary results are exciting. The presence of an extended distribution of ionized gas in between the two nuclei is confirmed, and the black hole is beautifully in the middle of the velocity distribution of this surrounding gas. This suggests that the black hole may have formed from the gas cloud, rather than being a runaway black hole or a black hole from an unrelated galaxy. A newborn black hole, the implications of the discovery. The discovery of the infinity galaxy and its supermassive black hole has significant implications for our understanding of the universe. If confirmed, this would be the first direct observation of a black hole forming through the direct collapse of a gas cloud. This would provide a new perspective on the formation of supermassive black holes and the evolution of the universe. The future of research, investigating the possibilities. While the researchers cannot say definitively that they have found a direct collapse black hole, the new data strengthens the case that they are seeing a newborn black hole. They will continue to analyze the data and investigate the possibilities, leaving us with more questions than answers. What do you think? Do you believe that the infinity galaxy holds the key to understanding the mysteries of black hole formation? Share your thoughts in the comments below. This could be the first witnessed birth of a supermassive black hole. Could we be witnessing the birth of a supermassive black hole? Supermassive black holes are among the most perplexing phenomena in the cosmos. These colossal entities, which can weigh anywhere from millions to tens of billions of times the mass of our sun, are typically found at the centers of nearly all galaxies. They serve as the gravitational anchors around which stars, planets, and clouds of luminous gas revolve in a complex cosmic ballet. However, the origins of these titans remain shrouded in mystery. Are they formed gradually, accumulating mass over time from a core as small as a single star? Or do they emerge directly from the collapse of massive clouds of material in space, so dense that they cannot resist the pull of their own gravity? Recent findings may shed light on this enigma. Astronomers have identified a pair of galaxies whose light has traveled for an astonishing 8.3 billion years. And within them, they believe they have observed a supermassive black hole in the process of formation. If confirmed, this would mark the first time we have directly witnessed such a phenomenon, providing a crucial piece of the puzzle regarding how supermassive black holes come into existence. We believe we are observing the birth of a supermassive black hole, an event that has never been documented before, states astronomer Peter Van Dokkum from Yale University. This significant discovery, referred to as the Infinity Galaxy, was made while researchers were investigating unusual cosmic structures in the JWST Cosmos Webb survey. The two colliding galaxies are arranged in a manner that resembles a figure eight or an infinity symbol. Each lobe of the Infinity Galaxy possesses its own bright nucleus, which houses a supermassive black hole. Intriguingly, where these two lobes intersect, a third luminous blob is visible. Upon detailed examination of this blob across various wavelengths, researchers were astonished to uncover the signatures of a third supermassive black hole located precisely between the two lobes of the Infinity Galaxy. We found ourselves asking, how can we interpret this? Van Dokkum reflects. A thorough analysis of the material surrounding this unusual black hole indicated that it is newly formed, situated within a vast region of hot shock gas. This observation supports a novel theory of black hole formation known as the direct collapse model. In this scenario, two disk galaxies collided, resulting in the ring-like structures of stars we observe. During this collision, the gas within the galaxies experiences shock and compression. This compression may have been sufficient to create a dense knot that subsequently collapsed into a black hole. Van Dokkum elaborates. While such collisions are rare, extreme gas densities like those observed are believed to have been quite common during the early epochs of the universe, when galaxies were first forming. Galactic collisions have long been theorized as a mechanism for the growth of supermassive black holes. When two galaxies merge, their central black holes are drawn together by gravity, ultimately colliding and merging to create a larger black hole. These galactic mergers are also thought to play a vital role in the growth of galaxies in the early universe. For instance, the Milky Way is believed to have experienced multiple such mergers. While this theory is well supported, it does not fully explain how the smaller, yet still supermassive, black holes at the centers of these galaxies originated. Increasing evidence supports the direct collapse model, but until now, we have not observed this process in real time. The Infinity Galaxy is situated roughly halfway through the universe's 13.8 billion year history, but the early universe was filled with dense clouds of hydrogen gas that could have collided, creating shocked knots of material in a manner similar to what we are witnessing now. Thus, this discovery strongly advocates for the direct collapse model as a plausible explanation for black hole formation in the universe's infancy. This is as close to a definitive proof as we are likely to achieve, Van Dokkum concludes. 2 research papers detailing this groundbreaking discovery have been submitted to the Astrophysical Journal Letters and can be accessed on archive. James Webb Telescope discovers rare figure 8 galaxy with forming black hole. Imagine stumbling upon a celestial object so bizarre and captivating that it seems plucked straight from a science fiction novel. Astronomers have done just that, discovering a galaxy shaped like an infinity symbol, with what appears to be a newly forming supermassive black hole at its core. This isn't just any ordinary galaxy. It's a cosmic enigma that could rewrite our understanding of how black holes are born and evolve. Led by Yale astronomer Peter Van Dokkum, the team behind this groundbreaking discovery has named the galaxy Infinity. This peculiar figure-8 structure is the result of a recent collision between two galaxies, creating a shape that scientists have never witnessed before. But here's where it gets controversial. Nestled in the heart of this cosmic spectacle is something even more extraordinary. A supermassive black hole that seems to be in the process of forming. Not only does it look incredibly strange, but it also has this supermassive black hole that's actively accreting a lot of material, explained Van Dokkum, the Sol Goldman Family Professor of Astronomy and Professor of Physics at Yale. The biggest surprise was that the black hole wasn't located inside either of the two nuclei of the merging galaxies, but right in the middle. We had to ask ourselves, how can we make sense of this? The findings, published in the Astrophysical Journal Letters, challenge long-standing theories about the origins and rapid growth of black holes in the early universe. Typically, black holes are found deep within the centers of galaxies, but this one appears to be forming between the two merging galactic cores, an unprecedented observation. This is as close to a smoking gun as we're likely ever going to get, Van Dokkum remarked. The team's breakthrough was made possible by data from NASA's James Webb Space Telescope, JWST, particularly the Cosmos Webb Survey. Additional observations from Hawaii's W.M. Keck Observatory, along with archival data from the Chandra X-ray Observatory and the Very Large Array, confirmed the presence of a powerful black hole surrounded by dense gas, forming in real time. But here's the part most people miss. This discovery could help solve one of astronomy's most perplexing mysteries. How did supermassive black holes, millions to billions of times more massive than the Sun, form so quickly after the Big Bang? One popular theory, known as the light seeds hypothesis, suggests that black holes grew from exploding stars over time. However, this timeline doesn't align with what Webb has already revealed. Massive black holes existed too soon after the Big Bang. This is where the heavy seeds theory comes in, proposed by Indian origin Yale astrophysicist Priyamvada Natarajan. It suggests that black holes can form when enormous gas clouds collapse directly. The catch, these clouds usually form stars, not black holes. Infinity might change that. In this case, two disk galaxies collided, forming the ring structures of stars that we see. Van Dokkum explained. During the collision, the gas within these two galaxies shocks and compresses. This compression might just be enough to have formed a dense knot that then collapse into a black hole. While such collisions are rare events, similarly extreme gas densities are thought to have been quite common at early cosmic epochs, when galaxies began forming, he added. So, what's next? This discovery opens up the new cosmic laboratory, a place where astronomers can study how black holes are born and evolve under extreme conditions. But Van Dokkum and his team are clear. More data is needed before anyone writes this into the textbooks. Still, and now, the Infinity Galaxy might be more than just a beautiful shape in space. It could be the first glimpse at a black hole coming to life. And that, in the far silence of the cosmos, is a story worth listening to. But here's a thought-provoking question. Could this discovery mean that black holes are more common than we thought? Or is infinity a one-of-a-kind phenomenon? Share your thoughts in the comments. Do you think this changes everything we know about black holes? Or is it just a fascinating anomaly? Let's discuss.